Hello everyone, welcome to chemistry classes. So in the previous session we have discussed about the measurement of electrode potential of the electrodes with respect to standard hydrogen electrode as our reference electrode. And in the previous session we have discussed about and we have calculated the electrode potential of copper electrode, electrode potential of zinc electrode, and by using those two data we have discussed and we have calculated the cell potential of Daniell cell. And you must be aware of these two results. The standard electrode potential of copper electrode is 0.34 volt and the standard reduction potential or standard electrode potential of zinc electrode is minus 0.76 volt. So what does this positive sign indicates and what does this negative sign indicates? Why copper electrode is positive and why the zinc electrode has got negative potential? So the positive potential and negative potential. So we can explain the value of electropotentials positive and negative with respect to hydrogen electrode. So here the electrode potential of copper is positive. The electrode potential of copper is greater than 0. So this indicates that the copper is more stable. The reduced form of copper is more stable than hydrogen ions. So here the Cu2 plus can be reduced to Cu in the presence of hydrogen electrode. So in the presence of hydrogen electrode, the reduced form of copper is more stable than hydrogen gas. So we were comparing the one side of our copper electrode and another side of our hydrogen electrode. So the standard electrode potential of the copper is greater than 0, means it is positive. This indicates that the reduced form of the metal is more stable than hydrogen gas. So means what? The hydrogen means H plus ion can reduce copper. H plus ion or hydrogen can reduce copper, but hydrogen cannot oxidize copper. Please remember, once again I will repeat. So the electrode potential positive indicates that the reduced form of the metal is more stable than hydrogen gas. If the electrode potential of any metal is found to be positive, that clearly indicates that the reduced form of metal is more stable than hydrogen, means this metal ion is reduced more easily than hydrogen ions. So this indicates we are comparing these two ions. So in these two ions, which ion is reduced more easily? So here in the presence of H plus ion, copper ions are reduced more easily to give copper metal. Means hydrogen can reduce copper, but hydrogen cannot oxidize copper. So here our hydrogen gas can reduce copper ions, but it cannot oxidize copper atoms. So here, so because of that reason, copper does not dissolve in HCl. So if I put the copper strip in HCl, in that HCl copper does not dissolve in HCl. Why? Because the HCl solution contains H plus ions. So these H plus ions cannot oxidize my copper. So our copper cannot be oxidized by H plus ions. So copper is reduced by H plus ions. It cannot be oxidized by H plus ions. So because of this reason, copper does not dissolve in HCl. And if you take the very same copper is placed in HNO3, if the copper is placed in HNO3, it dissolves. The very same copper is placed in HNO3, it dissolves. See here, HCl also contains H plus ions. It also contains H plus ions. Why? See here, HCl also contains H plus ions. Here, copper does not dissolve. HNO3 also contains H plus ion. Here, our copper dissolves. So, don't think that copper do some partiality. See here in HNO3, copper is dissolved because of presence of NO3 minus ions. Here in HNO3, copper is dissolved not because of H plus ions but because of NO3 minus ions. So because of NO3 minus ions, copper is dissolved. So Once again, here the electrode potential of copper is positive. That indicates that copper ions are more easily reduced than the H plus ions or hydrogen ions. Means hydrogen can reduce copper, but hydrogen cannot oxidize copper. So any electrode with respect to hydrogen, any electrode reduced with respect to hydrogen has got the electrode potential greater than 0. Here in this case the copper is reduced with respect to hydrogen electrode. So the electrode potential of hydrogen is found to be, so electrode potential of copper is found to be plus 0.34 volt. And here the electrode potential of zinc is found to be negative. Then what does that negative indicates? So in the same manner, in the opposite manner, here the electrode potential of this zinc is less than 0. The negative means what? This is less than 0. This indicates that zinc ions are more easily oxidized than the hydrogen. Means hydrogen gas is more stable than the reduced form of zinc. So reduced form of zinc means what? Zn2 plus 2 electrons gives Zn. This is less stable as compared with hydrogen gas. Means in the presence of hydrogen gas, zinc is oxidized. But zinc is oxidized. Zinc cannot be reduced in the presence of hydrogen gas. So because of that reason, zinc has got electrode potential less than 0 or negative electrode potential. If the electrode potential of a metal is positive, that is more stable than hydrogen gas. If the electrode potential of a metal is negative, that is less stable than hydrogen gas. So from the values of electrode potential, you can understand these many things. Not only these many things, from the electrode potential will understand so many data about the so many properties of our metal ions. So here the electrode potential, the standard electrode potential is highest for fluorine. And please remember, the standard electrode potential of fluorine is E0 is equals to 2.87 volt. For fluorine, the electrode potential is 2.87 volt. This is highest. So this indicates that here our fluorine gas, this fluorine takes 2 electrons and gives fluoride ions. Means the reduced form of this is highly stable than our hydrogen. Just we have to compare this with hydrogen. Means the fluorine can accept, can withdraw, can take electron from any source and it is reduced to give fluoride ions. Here the fluorine is reduced to give fluoride ions. And you might be remember that in a redox reaction, the component which is reduced is called as oxidizing agent. So here the fluorine is the strongest oxidizing agent. Strongest oxidizing agent. Why? Because this fluorine will abstract electron from any source and it is converted into fluoride ions. Means it will take electron from any source. It will take electron suddenly and it is converted into fluoride ions. Means the element or compound which takes electron, which is reduced itself, is called as oxidizing agent. Means our fluorine is the strongest oxidizing agent. And what about this fluoride ion? See here, this fluoride ion don't have any tendency to give back this electron. Each fluoride ion don't want to give back its electron. See here, means this fluoride ion don't give its electron. The component gives electron for the chemical reaction, that is said to be a reducing agent, isn't it? The component which helps for reduction is called as reducing agent. But here our fluoride ion don't want to give electron. Means what? this is weakest reducing agent. Weakest reducing agent. Here our fluorine is strongest oxidizing agent, as well as our fluoride ion is a weakest reducing agent, as it don't want to give electron. Why it is strongest oxidizing agent? Because it will snatch electron from any source and it is converted into fluoride ions. So the electrode potential of fluorine is highest. And also one more thing, the standard electrode potential of lithium. The standard electrode potential of lithium is lowest. It is around 0.3. Sorry. It is around minus 3.05 volt. See here. So what does this indicate? The standard electrode potential of lithium is weakest. Sorry, lithium is lowest. This is highest. This is highest. And this is lowest. The standard electrode potential of lithium is lowest. This indicates that lithium is strongest. Lithium is strongest reducing agent. Reducing agent. See here, the electrode potential of any metal is negative, indicates that it can lose electron very much easily. It can oxidize very much easily. As it is oxidized, as lithium is oxidized. What do you mean by oxidation? Loss of electron. As lithium loses its electron, it is converted into Li plus ion. Means lithium want to lose electrons very much easily, so it becomes strongest reducing agent. So you must be aware about these things. LiAlH4. You remember this? Lithium aluminum hydride is the strongest reducing agent, isn't it? In our organic chemistry we use lithium aluminum hydride as a strongest reducing agent, and also we use Dibal H like that. In all those things they contains lithium. Lithium is the strongest reducing agent, so it can lose electrons very much easily. See here, lithium loses electron, it converted into lithium ion. Then what about this lithium ion? Then what is the nature of lithium ion? See here, lithium ion don't want to accept electron. It don't want to take the electron. It don't want to reduce. Means if it is don't want to reduce, it must be a weakest oxidizing agent. So our Li plus ions is the weakest oxidizing agent. Oxidizing agent. See here, just by knowing the standard electropotential, how many information we can draw. See here, so as electropotential of fluorine is highest, this indicates that fluorine is strongest oxidizing agent and the fluoride ions is weakest reducing agent, and also the electropotential for lithium is lowest. This clearly indicates that lithium is strongest reducing agent and lithium ion is weakest oxidizing agent. So just by moving the electrode potential values, we can draw these many informations. And these galvanic cells or electrochemical cells are very much useful. So this is all about these electrochemical cells. These are very much useful. These are used to determine pH of the solution and the solubility product of the solution, and they are also used in the potentiometric titrations. And one more thing, and so yesterday we have discussed about the standard hydrogen electrode. In that standard hydrogen electrode we have used platinum. See here, that platinum is called as inert electrode. Inert means what? Non-reactive. Inert means non-reactive. Inert electrode. So there are some electrodes in our chemistry, we use them. Those electrodes are inert in nature, so like platinum, gold electrode, we can use silver electrode, or we can use calomel electrode. So those electrodes are they are inert electrodes. That why they are called as inert means they do not participate in the chemical reaction. Those electrodes do not participate in the chemical reaction, but they provide their surface for the chemical reaction. Those electrodes they just provide their surface for the chemical reaction, and also for conduction of electrons. They give surface for the conduction of electrons. So here the inert electrode means what? The component of the electrode which is not taking part in the chemical reaction, but it gives its surface area for the chemical reaction. That is called as inert electrode. Example for this is platinum electrode, gold electrode, silver electrode, etc. So I have taken two examples here. The platinum is used in the hydrogen electrode as the inert electrode. So we already know about this hydrogen electrode. See here, the cell representation of hydrogen electrode, the half cell representation of hydrogen electrode is platinum hydrogen gas in the presence of hydrogen ion solution. See the chemical reaction taking place in the electrode. H plus electron gives 1 by 2 H2, reduction of H plus ion. Do you find platinum in this reaction? No. Here only hydrogen is taking part in the chemical reaction. It is just an audience. It is just like a audience. So it gives its surface area for the chemical reaction, but it will not take part in the chemical reaction. And the very similar example, platinum is used as inert electrode in bromine electrode. There is one more electrode known as bromine electrode. In bromine electrode we use platinum, as we use the platinum in hydrogen. In the very same manner we use platinum in bromine electrode. So here this is the half cell representation of bromine electrode. So in this cell the chemical reaction taking place is the bromine gets electron and is converted into bromide ion, reduction of bromine. So we cannot find platinum in this chemical reaction. See here, this is my electrode. In this electrode, this chemical reaction is taking place. Our electrode consists of platinum, but the platinum is absent in the chemical reaction. Means the platinum do not participate in the chemical reaction. It will provide its surface area for the chemical reaction. So this is about the electrode potential. And the one more last thing, and right here, electrochemical series, or it is also called as metal activity series. Electrochemical series. Electrochemical series. It is also called as metal activity series. About this you have learnt in your first PUC. See here, the arrangement of metals increasing order of their standard reduction potentials. The standard reduction potentials is called electrochemical series. Is called electrochemical series. Electrochemical series. This electrochemical series also called by another name known as metal activity series. This electrochemical series is also called as metal activity series. The arrangement of metals in the increasing order of their standard reduction potential or standard electrode potential is called as electrochemical series. So all the elements, the electropotentials of all the elements are written in a order, increasing order. That increasing order forms a table. The table is known as electrochemical series or metal activity series. Okay, so I hope all of you understood about these all the things, and in the next class we will going to discuss about the Nernst equation. Okay, thank you so much for watching.